4.3, modeling with quadratic functions. So a couple of things. There is review here from chapter 2, but it's adding a little bit of a twist. So first, write a parabola in standard form with these points. So if you remember, standard form looks like this. Remember that C is your y-intercept. So if I look at these points, it gives us C. C, my y-intercept is 0. So I already know that C is equal to 0 here. So I'm going to write that over here. C for sure is equal to 0. So now what we have to figure out is this. Since we know C is 0 because of that y-intercept, I can use these 2 points because this is my x and this is my y. So when I plug this in, I'm going to have 2 separate equations. So this point right here, this first point, if I plug it into this equation, it says y equals a times b squared, or x squared, plus b times x. I can also do that for this point. So now my y is 6. So 6 equals a times x squared plus b times x. And I can simplify both of those 2 equations. So my 2 equations that I'm going to have here is negative 2 is equal to negative 1 squared is 1a. This becomes minus b. And now this equation I'm going to have 6 is equal to, this again, 1, and this will be plus b. Now we have a system of equations. What? Yeah, I know how to do that because I mastered chapter 3 because I'm sweet. So I'm going to do elimination because these are already opposite each other. So I'm going to have 4 is equal to, when I add these 2 together, 2a. So divide by 2, I get 2 is equal to a. Now I can plug that back into my equation, whichever one of these you want. So I'm going to plug it back into this one, just because. So negative 2 is equal to 2 minus b. Subtract 2 on both sides. Negative 4 is equal to negative b. B is equal to 4. My overall answer, y is equal to my a value is 2x squared. My b value is 4 plus 4x. You could put the plus 0 there if you wanted to, because again, we know that c is 0. I want you to pause the video and try b by yourself right now. Whoa, that took me a while, guys. I mixed up right here. I plugged my y value in. It can be that simple to screw up. So, but your overall answer should be y equals negative 3x squared plus 1x plus 0. Again, you don't have to have that. Negative 2 is what you're equal to. Negative 4 is what you're equal to. Plugging 1 in for this one, negative 1 in for this one. I plugged negative 4 in there first, and then I was very confused. But if you want to check over my work, bing, bada, boom. Here, quadratic regression, and this really is where we have review. So we can put this stat. So this is review. Push the stat button, enter. So we can edit. So you want to arrow up, clear, arrow up, clear. We're going to put this right here into my time. So we have 8, 10, 12, 2, 4, 6. Here we want to have our temperature. So 52, 64, 72, 78, 81, 76. Now this part is review. Now this part we go to stat, calculate. We typically have gone to linear regression, but now we're dealing with quadratics, hence the quadratic regression. So quadratic regression is number 5. So you can either type 5 or go down to 5. Push enter. Now we're given all of our information. So if I look at this r squared, seeing that this is not a very good equation. So one thing I could do is, looking at these two, is let's go back to the data. So when I'm talking about data, when you're talking about time, actually they tend to use this in the military. If I go back to this, if this is 12, this actually should have been 1 or 13, 14, 15, 16, 17, 18. So when we're talking about time, you want to make sure so that it's one variable, because otherwise we would repeat. So if I go back to stat, edit, that's good, that's good, that's good, 14, 16, 18. And some of you all who are doing this might have thought, hey, I kind of thought maybe that was a little peculiar. So we want to make sure that says L1, that says L2. Now, that is a much better equation, much better. So my equation of my trend line, my quadratic model, is y equals, I still want 4 decimal parts. It tells me my A is negative 0.468, and then that will round up to another 8, x squared. My B would be plus 14.716, round to up, x. My C is negative 36.1214. It says predict the high temperature for the day. So when I'm looking at this, I'm going to go to y equals, and go to negative 0.4688 x squared, and then plus 14.7161 x minus 36.1214. Now I'm going to graph this just so I can try to understand what's going on here. I can't see it. Typically we deal in a 10 by 10 grid, but now that we're talking about things like my y-intercept's at negative 36, I'm going to go to zoom, and I'm going to zoom out. You have to push enter to make sure to zoom out, hoping that at some point I'll see my graph. It is negative. Looks like it's a very wide graph because this is a fraction. So that means that's going to be compressed. I'm going to push enter again to zoom out again. Hopefully at some point, I'm going to zoom out again. It's thinking. See how my calculator's thinking? So your graph should look something more like this. I forgot my decimal point when I looked back. So if I want to figure out the highest temperature of the day, highest temperature, that would be like a max. So it's someplace up here. Now I could keep going to zoom out if I want to, but I'm going to go to window. This is going to change how much shows up on my screen. So if I go to window, I just want to move my maximum, my Y. So I'm going to try to go to 100 and graph that and see if I can see the curve. Wherever there's a curve, the turning point with the vertex. Look, there it is. So I want to figure out what this vertex. I could definitely do this like how we have done in the past, opposite B over 2A, and figure it out that way. I also just want to show you on the graph. I can figure out stuff on my graph with this information right here. So I'm going to go to calculate. See that right there? So second, trace to calculate. And I want to figure out my maximum value, that 4. So I'm going to type in 4. Now this says left bound. So this is saying this is the point I want to look for. I want to move this bug, is what I call, someplace on the left-hand side of this point. So I'm going to move it here, and I'm going to push enter. Now this says right bound. So now I need to move this bug someplace on the right-hand side. So here's the point I'm looking for. So now that's on the right-hand side, push enter. Now this is saying, guess about where you think that point is. So this is where I would say, here's a guess, and I push enter. This is giving me my point. So I'm going to say my vertex slash my max, I'm going to write down over here, is 15.6955, comma, 79.3669. So if I predict the highest temperature, when I'm thinking about that, temperature was my y value. So here, this is my y value of my vertex. That means the temperature was at 79.3669 degrees. That was the highest. It says, at what time does the high temperature occur? Well, that was my x value. So military time would be 15.6955. However, we're talking about time, typically we would say AM or PM. So if I subtract 12, so that's military time. So if I subtract 12 from that, that's 3.6955. I would say estimate time would be about 3:30 p.m. Why 3:30? Because this is over half. So, or you could say 3:45. Either of those would help. I want you to try to do the next one by yourself. So you should have figured out to put for 3, 15, 6, 18, 9, 21. And you should have gotten this in your graphing calculator, 4 decimal spots. So now again, you want to figure out what your vertex is of this. So either you can try to use the graphing calculator, or else you can use the opposite B. If I use opposite B, it would be opposite B 7976 over 2 times A negative 0.3294. And that would be your X value. So I want you to figure out your vertex whichever way, either with your graphing calculator or the other way. So I'm going to show you on the graphing calculator too, but this is what I got for my x and y value for my vertex. So if I start at zoom standard, I don't see the whole thing. So again, you can zoom out. I know already that I might just want to go to the window. So I'm going to go to the window and I'm going to do my x max, let's say to 50, and my y max, let's say to 50. And that's because I know that's going to be in the first quadrant. I'm going to go back to graph and hopefully I can see my curve. Oh, I can't. So it's someplace up there though. So I'm going to go back to window and I just need to get higher for my y value. So my y value has to extend. So I'm going to go to 100. Now I can calculate that vertex because I have that turning point. So again, I'm going to go to calc. So I push second trace. I want that maximum. Following the directions, it says left bound. So on the left-hand side of the point I'm looking for this point. Enter. It says right bound. Right-hand side of the point I'm looking for this point. It's on the right. Enter. Guess. So these arrows should be pointing to each other if you're doing this correctly. Enter. Now my guess is 14.871. That looks right. And 88.4258. So this is my vertex. Now I can answer these two questions. Predict the high temperature of the day. My temperature is my y value. So my highest temperature of the day was 88.4258 degrees. And at what time does that occur? That's my x value. So if I subtract 12 from that, it's 2.871. So I'd say probably 2:45 p.m. Again, this timing right here doesn't have to be exact. We could get it exact, but it doesn't have to be exact. So as long as it says 2 and then definitely past the 30. And there you go. Easy peasy lemon squeezy. Have a great day.